Hello everyone. Today we're going to discuss and write the C program for varying gamma ray intensity attenuation using high purity germanium detectors. So at first we include the libraries, that's stdio.h, conio.h and math.h. We keep the float empty. With writing the formulas, we'll input the variables in the float column. In main, at first we print a welcome note and then print enter the value of the raw intensity. That's basically the intensity at zero thickness of the material, and then density of the material under consideration. And after that we print enter the value of first attenuated intensity and the first value of thickness of the material. Those are determined by I1 and X1. Similarly, we also print the value of the second attenuated intensity and the third attenuated intensity as I2 and I3, and the value of the second thickness of the material and the third value of the thickness of material as X1, X2 and X3. Uh, After this, we write out the formula as mu1 equals to log of I0 minus log of I1 divided by R into X1. And similarly, we write the formula for mu2 and mu3, and we find the average value of the mass attenuation coefficient as the average of these three values, mu1 plus mu2 plus mu3 by 3. And now we print the value of the mass attenuation coefficient for the first intensity in centimeter square per gram as mu1, the second one as mu2, the third one as mu3, and then we print the average value of the mass attenuation coefficient for the given material in centimeter square per gram as mu. As we can see that this mu value is different from the empirical value given by the NIST XCOM. This happens because of several factors, few of them being the composition of the aluminium disc not being uniform and ideal. The aluminium may be oxidized at several places. The experimental setup is not ideal, and there are some symmetric uncertainties in the experiment. This needs a mass attenuation coefficient correction factor, which will be described in a later video. Thank you. Please like, share, and subscribe.